company called StockX. So I'm an engineer on the payments team, payments and payouts. So my team basically manages whatever. Let me first introduce about StockX. StockX is a marketplace, majorly for catering towards all over the world, but mostly towards Europe and US markets, where we sell a lot of sneakers and apparel, etc. And StockX basically works on a bid-ask model, where buyers can add different bids for any product they wish to buy, and sellers can place an ask for that particular product. And when there is a match between the buyer's product, the buyer's bid, and a seller's ask, there is a matcher in between, and once there's a match, there's an order placed. So this is the basic model which we work on. In this entire ecosystem, my team basically manages the payments part of it. So we are responsible for taking the amount from different buyers and also securely giving it to the taking StockX cut and then securely giving it to the sellers. So in this context, we call it a payout to the sellers. When we are giving out the money back to the sellers, we call it a payout. So initially, we had a monolith system in place where there was our entire architecture was part of a very huge monolith, which was a PHP based service. And then we decided to pivot from there and then created something called a payouts microservice. And we started pivoting and we started moving some of the functionalities from there. And then slowly, a couple of years ago, serverless and lambdas were all the rage, right? And then as well as step functions. So we also decided to integrate that into our system. And step functions basically allowed us to, allowed these payout workflows to be broken down into multiple discrete steps. And each step could be an eligibility check, it could be a duplication check, it could be a payout initiation. So there are multiple nuances to when a payout is given to a seller. And each of these steps was represented using a lambda or a function. And then there was a state associated. And what we thought was that this would give us a clear visibility into the workflow, making it easier for us to track. And one major advantage was that we wanted to retry particular functions. Let's say we want to do some kind of a validation, and that validation failed from our vendor side or from our system side. We wanted to have the ability to retry that particular function or that particular step itself. And the promise of serverless was to integrate these things. And like I mentioned, we could also make it pretty much modular. Each step could be implemented and deployed separately. And the promise was that we can easily maintain and update different components without affecting the entire architecture itself. And another thing was the scalability aspect, right? The serverless architecture itself supports automatic scalability and does not require any kind of server management. And of course, our entire system was integrated within AWS, and having the ability to use other AWS services like SQS or EventBridge was an added advantage. So moving on, let me give you a little more context on what our initial architecture was. So it was like a textbook serverless system which we used to implement a very complex workflow. It's very elegant in theory, but very cumbersome in practice, right? The actual business logic, like checking for balances, formatting data, all these were different modules which were part of the Lambda functions. And step functions is a layer on top of that, which basically coordinates all these all these different lambdas, and then manages the flow. What we didn't realize is that for each of those steps, we were also paying an extra fee of state management, and every state transition had a cost associated with that. And another key complication, I think I forgot to mention it before, is that part of our system, like I initially mentioned, was a microservice, and part of our system was in the Lambda. So what was happening is we had to have a kind of sync between these two systems, and we used for the data management between these two to keep the database in sync. We used AWS DMS, right? What we observed is that DMS was great for one-time migrations and things like that, but when it came to keeping a constant sync between two of these systems, it was adding an additional overhead. And so we and two different microservices or two different systems actually meant that two different deployment pipelines, two separate pipelines to look at when something critical goes down. And so basically it seemed like the complexity was baked into the system itself. So how I think a little more into costing and these things. So after an initial POC, and then we started moving most of our workloads into the Lambda systems. And the first red flag was an unpredictable cost, right? While individual Lambda cells were cheap, like I mentioned, the state transitions or maintaining that state drove up the bill very quickly. And the real headache was the maintenance. We spent huge engineering hours just to keep those Lambda upgrades and patches updated. And this actually diverted the focus of engineers from the key feature development to, infrastructure upkeep. And of course, another key point was most of our services were using a tool called Datadog for our monitoring. And only our particular microservice or our particular payout service was using the CloudWatch. And we couldn't integrate these two together. It was difficult for, let's say we had a critical bug in our system and we wanted to debug it. We had to get data from multiple sources to even debug one particular flow. Let's say for a particular order, if the payout failed for some reason, we had to go through multiple dashboards and go through multiple systems just to figure out what the error was. And this actually also caused a lot of uncertainty and, created kind of a risk for us. I think I covered most of these. One other thing which I wanted to, stress upon is the architectural isolation. So isolation, our entire, other engineering services or microservices were using a certain set of tooling. And only our payout service was using a different set of tooling. And it was difficult for us to adopt to the upgrades in the security policies which the company was making. And there were platform engineering teams who were upgrading our CI/CD pipelines and all that. But this was kind of creating a bottleneck there. And we were wasting valuable engineering hours just to keep up the service. So what did we do? We didn't replace one cloud solution with another. What we did is a phase-wise migration. We, the first phase, what we did is we created the microservice, the microservice just to take care of the entire Lambda system. We introduced this new Money-Payouts, we called it, and we didn't force any of the upstream services to use this immediately. The old payout service or the old endpoints were still existing, just that it was like a relay to the new service. This was phase one. And then once phase one was, we kind of ramped up the traffic and it was working and we were confident about it. Then we went to phase two, where the upstream systems directly, integrated with the new service. And then this kind of minimized the disruption to our internal teams. So immediate wins, I think big elimination is the cost. The primary goal for phase one is to eliminate all the DMS and AWS Lambda and all these different other functionalities which we're using, and this was achieved in the phase one itself. And the observability, like I was mentioning, because we were able to integrate all the different CloudWatch and Datadog into one place, it gave us centralized dashboards, and we could finally see the health of this entire system real time. And this also gave us the ability to have more effective alerting, and more actionable alerts were possible. So yeah, if you know about Datadog, it has quite robust system of APM where different traces are provided by them, and you can go through the entire life cycle of an order, or let's say a payout, and kind of debug it whenever we have to debug, right? And I think this is pretty much what I covered. Like there was a improved observability, enhanced flexibility. So one other thing was our initial lambdas, which we were doing. We were very tied up to a particular vendor, and we wanted to come out of it. And this kind of had a multi-month project. We had to break it up into different, if we have to integrate a new vendor into that particular system, it was very complex for us to do it. But moving to a microservice architecture, it was it made us much more flexible, and the cost efficiency is not just for one time. It was like a sustained cost efficiency, right? And the new system also automatically benefited from the platform level DR, the disaster recovery as well, because it was following the same protocols which the rest of the company was, right? And I think I wanted to highlight that this is not like an anti-serverless talk, right? It's like anti-unwise architecture talk, like why that was not right for us. So serverless, I think it's an incredibly powerful tool. But the ideal use cases would be something where the system itself is inherently stateless, right? Think of it like a glue code. So you have multiple modules in between, and you're trying to just communicate one task with another task without the state involved in between. So for example, it could be you want to resize an image and upload it to S3. Lambda would make it very easy to do that. Sending a webhook notification, or if you are running like a one-time cleanup task, or even if it's periodic, just a cleanup task which does some kind of a cleanup for your this thing. And it's also great for low volume or infrequent tasks. Let's say batch jobs that run once a day, or internal dashboards that see less traffic, those kind of things. Another region it would really shine would be development of MVP. MVP is like minimum viable product. So if you want to test a new product and push it to market quickly, you can obviously use something like a serverless. And then once it's matured and we've already seen a product market fit, then you can re-architect and build to scale. For our use case, of course, it was a very complex use case, and there was a lot of orchestration which had to be involved just to keep up the multiple tasks which was part of it. And so that's the reason why it was not useful for us. But when you use it as a glue, it is simple, and it will definitely be helpful in those cases. So when we moved out of that sweet spot and we are going into that complex zone, I think that is time we decided we should pivot. I think key lessons learned, pretty much what I've already covered. Embrace pragmatic pivots. We were not afraid to move away from hype technologies when they were not serving our purpose. And major important thing I think you've heard throughout all the sessions as well, where observability makes a crucial part when you're dealing with very high traffic or consumer facing systems, or any system for that matter. You should be able to prioritize maintainability and observability from day one. The ability to have monitors and ability to have debug a particular system is not optional. Then again, calculating true costs. I think this would be we had a lot of operational overhead just to maintain the lambdas, and the debugging time was increasing, and there was a huge impact on the development velocity, which was not just about infrastructure but also the entire business use case. I think the final thing would be stay pragmatic, not dogmatic. The best architecture is the one that solves specific problems effectively and efficiently. So yeah, I think that's the end of the talk. You can connect with me on LinkedIn. And
thank you so much, Bhavana. Do we have anybody who has questions?
So this serverless is serverless is very famously advertised by Netflix, that is used heavily. Why did it not work for you?
Yeah, I think.
I mean, I know that's the entire talk, but still I feel that, was there any second thought, like, have you made some comparisons?
Yeah, so I think we tried to get it work for a couple of years. We kind of had the system in place for 3 years at least. And the operational overhead was too much, in the sense that the tooling our entire company was using was completely different than the CDK which the Lambda was using. So I think that was one crucial factor for us. And other thing that we had a lot of cost associated with it, and we wanted to make it a little more cost effective, and that's the reason why we pivoted into it.
So is OpenWhisk or OpenFaaS evaluated from the cost perspective?
No, we didn't evaluate.
Okay.
Anyone else?
I want to understand what, you said when there is stateless use case, then only Lambda is useful. So I want to understand what stateful use case was there from your case in detail little bit that was not supported by Lambda serverless.
Okay, so basically our overhead was maintaining it was not just about stateless or stateful use case. We had two different systems. One was doing a user management, and the other part was doing the actual payout processing. And maintaining a sync of DB between these two was very difficult for us to. That was adding an additional overhead there. So that's the reason why we kind of thought of migrating the entire thing into a microservice architecture instead of keeping these two separate.
Have you done the processing in two different Lambdas or only single one? Was that
we had different Lambdas for different processing. So one was doing a validation check. One was doing the input of that was going to another function which was doing another step where is eligible for payout. So there was some kind of currency conversions which were involved. So there were a lot of, and there were on top of it there are also some compliance checks which we have to do. So there were a lot of different checks which each of the Lambda function was taking care of.
Okay. Thanks.
Hi, thanks for the talk. I just want to understand, you said you compared with the microservices, microservice cost. So these microservices are deployed in Kubernetes, or how do you compare, really?
See, the comparison.
That is the reason I asked this question is,
comparison, right? The thing was, it started becoming very difficult. It's a very specific use case, which I presented, but it started becoming heavy in the sense that we thought it will be a very easy solution, and that's why we started, in the Lambda part itself. But having the overhead of all these different steps which we had to take, that kind of made us feel like it would be better to just go with the microservice architecture.
Okay. So may I know that what current stack your microservices is being deployed to?
We have a Kubernetes only.
Kubernetes. Okay. Thanks.
All right. Thank you so much. Please give her a round of applause.